So in this video, we are going to discuss about general second order active filter with variable gain. This we have already discussed in using low pass filter, right? Second order means it is a two-pole active filter which is proposed by Salon key filter. So here instead of voltage follower circuit, I have added an RI and RF resistor so that for non-inverting amplifier Vout I can write it as VB into 1 plus RF by RI. Okay, so that is this value is nothing but A, and you substitute the values and you can identify my H of S value. H of S that is nothing but Vout by V, that is equal to this I can write it as A divided by 1 plus Z2 by Z4 plus Z1 by Z4 plus Z1 Z2 by Z4 Z3 plus 1 minus A Z1 Z3. So I can also write it like this. Okay, so since I need to find second order Butterworth high pass filter with variable gain, I'm going to substitute y1 is equal to capacitor, y1 and y2 is equal to capacitor, and y3 and y4 is equal to 1 by r3 and 1 by r4. Okay, so I'm going to substitute in this equation. Okay, so if I substitute, I will get A divided by 1 plus S divided by 1 divided by S C square C2 R4 plus 1 divided by S C1 R4 plus 1 divided by R4 R3 S square C1 C2 plus 1 minus A divided by R3 S C1. Okay. So here I am going to multiply and divide the whole term by S square. So if I do it, so I will get this equation. Okay, I am going to take S as common. So if I take S common, I will get 1 divided by R4 C2 plus 1 divided by R4 C1 plus 1 minus A divided by R3 C1 plus 1 divided by R4 R3 C1 C2. So in this I am going to substitute R4 and R3 is equal to R and C3 and C4 is equal to C. So if I do it, so I will take this whole term as 3 minus A divided by RC. Okay, that is what I have written here. Here I can write it as R square C square. Okay, so what I am going to do is I am going to substitute omega L is equal to 1 divided by RC and alpha is equal to 3 minus A in this equation. Okay, in this second equation. If I substitute, I will get the A S square divided by S square plus S omega L 3 minus A plus omega L square. Okay, so this is your H of S. Okay, so I am going to divide the S square term on both sides. So I will get A divided by 1 plus omega L 3 minus A divided by S plus omega L divided by S the whole square. So I can write alpha is equal to 1 by root 2 for Butterworth filter. Okay. So I can write root 2 of omega L divided by j omega. S is nothing but j omega plus omega L divided by j omega the whole square. So this I can write it as S. So what is now my S? S is nothing but omega L divided by j omega. So this is your normalized value. Okay. So h of s I can write it as so if by substituting I'm taking this equation, okay, and I'm going to separate in this term. So this I can write it as a divided by 1. If I subtract j and j here, I will get 1 plus j root 2 omega L divided by omega minus omega L square divided by omega square. Okay. So this is what I have written here. Okay. Okay, so now if I take modulus of this term, okay, if we take modulus, I will get root of 1 minus omega L square divided by omega square the whole square plus root of 2 omega L the whole square divided by omega the whole square. So by applying a minus b the whole square formula, I will get this one. So here these two get cancelled out. So I'll get h of j omega is equal to a divided by root of 1 plus omega L divided by omega 4 root 4 power 4. Okay. So if instead of omega I can substitute f. So the omega L and omega becomes fl and f. So instead of 4 I can write as 2n. Say n is equal to 2. Since the order is 2, second order, and alpha values root 2 for second order high pass filter. So let us discuss on problem based on this. If lower cutoff frequency, that is what they are asking. For second order Butterworth high pass filter, find passband gain and also plot frequency response of the filter. So they have given R value, that is your R3 and R4 values equal to 16K, and C1 and C2 value is equal to 0.01 microfarad. So by this I can calculate F is equal to 1 divided by 2 pi RC. So since both values are same, if you substitute I will get 1 kilohertz. Okay, and we know that A is equal to 1 plus RF divided by RI. So that is nothing but 3 minus alpha, that is nothing but 3 minus root 2. So that value is 1.586. Okay. So if RI is 10K, what is RF? RF is equal to 1.586 into 10K. Okay. So we have find out this values, and if I want to find the voltage gain, that is nothing but A divided by root of 1 plus FL by F the whole power 4, right? So this is nothing but 1.586 divided by root of 1 plus this FL I have already found out, that is 1K divided by F power 4. M. So you have to substitute the different values for F. Okay. So if F value is 100, substitute here. So therefore the voltage gain. Okay, voltage gain becomes 0.02. So another value you substitute 700. You will get answer as 0.70. And you substitute 3000. Okay, so you will get answer as 1.58. And likewise 30,000. You get the answer as 1.59. Okay. So if I substitute 1 lakh, you will get answer as 1.59. So if I want to get it in dB, voltage gain in dB, you have to take 20 log of this value, right? So if I take 20 log of this value, that is nothing but minus 35.99. And this is 4.01, 4.01, and this is 3.95, and this is minus 3.1. So if you see the frequency, if it increases, the frequency is increasing omega J in dB, right? So initially it does the maximum can go up to 4. Okay. So if you take 20 log of A, 20 log of 1.56, it will go up to maximum of 4 point something. Okay, so the maximum value it reaches is this one, 20 log of A. So you can see whenever the frequency is increasing, the gain started to increase, right? So this is how it is, and so it is 4 dB, and at this point you can find the value of FL, right? FL is nothing but 1 divided by 2 pi Rs. And here you can note that this is nothing but 40 dB per decade, right? So this FL value, that is what we found out as 1 kilohertz. So if I found the value of 1000, it is nothing but 1.12, and the answer is 1. Okay, so you can see it is nothing but minus 3 dB value. It is 4, now it is 1. Okay. Okay.